Hi guys! In the last lesson, we learned about reflection symmetry. Today, let's look at the reflection symmetry of various shapes. I'm going to start by looking at 6 important shapes and checking how many axes of symmetry does each shape have. Let's start with an isosceles triangle. The isosceles triangle has 2 equal sides, but the third side is not equal. Let's try folding the isosceles triangle from the first side. The 2 sides overlap perfectly. This means that the center line becomes an axis of symmetry. Let's try folding it horizontally this time. Oh no, that did not work. Let's try it again from another side. Again, the 2 sides don't overlap. This means that the isosceles triangle has only one axis of symmetry. Let's now look at a square. When we fold the square horizontally, vertically, or diagonally, the sides of the square overlap perfectly. As you saw, the square has 4 axes of symmetry. We're now going to look at a rectangle. When we fold the rectangle vertically, the 2 sides overlap perfectly. That's the first axis of symmetry. Horizontally gives us a second axis of symmetry. But diagonally, the sides don't perfectly overlap. This means the rectangle has only 2 axes of symmetry. Now an equilateral triangle. All 3 sides are equal. So when we fold it across the first side, we get our first axis of symmetry because the 2 sides perfectly overlap. From the second side and the third side, we see exactly the same thing happening. This means that the triangle has 3 axes of symmetry. Let's start with a regular pentagon. A regular pentagon has all 5 equal sides. When we fold it from one vertex, the 2 sides overlap perfectly. From the second vertex, the 2 sides overlap perfectly. If we keep trying this from the different vertices, you'll notice that from each vertex, the pentagon folds perfectly onto the other side. This means that the pentagon has 5 axes of symmetry. Let's now start with our final shape, the regular hexagon. The regular hexagon has 6 equal sides. When I fold it from the top vertex, it also matches the bottom vertex. This gives us our first axis of symmetry. When we do this 3 times, we've now run out of vertices. So let's try folding it across the different sides. When we do this, we get 3 more axes of symmetry. Three plus 3 gives us a total of 6 axes of symmetry. Bye guys!